Hello, Accelerated Math 7-8 students. We are working on Module 14 and this is Lesson 22. The name of our lesson is Constant Rate Revisited. Aha, constant rate. That was Lesson 11. So exactly 11 lessons later, we're revisiting it. How funny is that? Okay, so the goal of our lesson, today we will use constant rates to write linear equations and then compare the constant rates to see who is faster. Okay, because constant rates mean that you're doing something consistently at the same speed. Okay, how do you compare constant rates to determine which is faster? You will learn. All right, so things to know. Who is faster? Max can run 3 miles in 23 and 25 hundredths minutes. Adam can run 8 miles in 61 and 2/10 minutes. Write an equation with two variables for each boy's running time. So remember, you have to find your unit rate, which becomes your m, or your slope, and then we also have to figure out what the y-axis or y-intercept is from your slope-intercept form. All right, so max. So the first thing that I would suggest that you do is establish what your unit rate is. So we know that time usually is on the bottom. So we're going to have compared miles to minutes. And we know that Max can run 3 miles in 23.25 minutes. Okay, so we're trying to figure out how far he can go in 1 minute. Yeah, let's do 1 minute, not 1 hour, 1 minute. Okay, so in order to do that, we have to take 23.25 and divide it by 23.25. So we're going to take 3 and divide it by 23.25. And you can do that with a calculator if you want. You could also use another fraction, remembering that this is really 3 divided by 23 and 1/4 if you wanted to do that as well. Either way, I'm actually going to use a fraction because I like multiplying by the reciprocal, which is easier for me. So I know that 23 times 4 is 92, plus 1 is 93. So I'm going to multiply by 93/4. What you do to one side, you have to do to the other, so 93/4. And then I know that 3 times 3 is 9, and 3 times 9 is 27, and I'm dividing that by 4, and so I'm going to take 279 divided by 4, and I get 6, 3, 9, so that's going to be 9, and 1/4. So I know that in 1 minute, I can go, did I do that right? 23 times 4 is 12, regroup 90, 92 plus 1 is 93/4. No. No, I had to multiply by the reciprocal. Oh, duh. Okay, sorry. So I need to flip these. Bink, bink. So this should be 4/93. There we go. See, even Mrs. Nelson gets thinking too fast. Okay, so let's try that again because we got the exact same answer. Okay, so let's try it again. So 3 times 4 is 12 and 93. There we go. That looks much better. So we have 12/93. And if you want the decimal, you can figure that out by going 12 divided by 93. And so we know that 93 can go into 120 one time. So that leaves us with 7, 2, 0. And can it go in there 3 times? Nope. 2 times. So that would be 6, 18. That would be 4, 84. Okay, and then probably 8. So you get 0.128 something. So that would be 24, 72, 74. So that would be 6. So somewhere around in 1 minute, they can travel, max can travel 0.128, and we'll go ahead and round it, miles. So remember, this is miles and this is minutes. So that's how fast Max can go. Okay, now let's do Adams. And it says Adam can run 61.2 minutes after 8 miles. So again, we're doing miles per minute for this one. And so we get 8 miles in 61.2 minutes. So that's an hour and 1 2/10 minutes. So we want to find out how far he can go in 1. So we divide that by 61.2, divide that by 61.2. So I guess I'll just do that this time. So we're going to take 8 and divide it by, we'll actually do 80 because we have to move the decimal over 1. 612. Yuck. So 612 can't go into 8, 612 can't go into 80 evenly, 612 can go into 801 times, so 612. So we have 7, 9, 10, 8, 8, 1. And now maybe 3. I don't think 3 is going to work. Actually, no, 3 is not going to work. So we're going to go 2. So that's 4, 2, 12. Subtract, so that's 7, 6, 5, 6. And then bring down another 0. And we're going to say, oh wait, that's not enough. Okay, let's try 3 and see what happens. So that's 6, 3, and 18. Wow, it did. So that would be a 4, 6, 3, 7, that would be 4. That's an 8, so that doesn't exist. So it would be 4, 4, 0. Okay, 4, 4, 0. So that would be, can't even be 2. Can't even be 1. So that's a 0. Okay, so now that's 4,000. So let's go 6. So about 0.131 for Adam miles in 1 minute. Okay, so this is our unit rate for each boy. Okay, so now it says, graph the boys' running times on the graph. Use different colors for the lines. Okay, so we know what the unit rate is, and so basically you're going to graph for every 1 minute they can travel that much time. So in 23 minutes, okay, so here's how we're going to do this. Is the x-axis is the minutes, and the y-axis is the distance. And so in 61 minutes, this graph is not going to work at all. So I'm going to draw this graph over here. And we're going to count by 10 minutes. So here's the 0 minutes. So this would be 10, 20, 30, 40, 50, 60, 70. Okay, so those are minutes. And then this is going to be miles. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And we're going to plot what we know. So in 23 and a quarter minutes, so let's say 25 is about there. Different color. 25 is about there. So 23 would be 24, 23, 22, 21. So 23 and a quarter, so it would be about there. And you can go 3 miles. So this is Adam. No, this is max. So there's one dot, right? And then his other one is in 1 minute, so clear down here, and he can go 128 thousandth. Yikes, that's tiny. So I would say about here, and then 0. So his line looks something like this, and this is max. Okay, and now let's do Adam. Adam took 61 and 2/10 to go 8 miles. So 65 is there. 61 would be about here, and 2/10, so just a little bit off of that, and the 8 is here. So about there. And then he was at 0, and his unit rate was in 1 minute. He went a little further, so about there. I mean, not even that much probably, but so his line goes like that. This would be Adam. Okay. My graph is not really that helpful. And, oh, I'm so sorry you didn't get to see any of that. So basically, what we learned is that Adam is faster because of the unit rate. He travels 131 thousandths of a mile in 1 minute, and Max only goes 128 thousandths in 1 minute. So who runs faster? We're going to say Adam. So the graph should actually be steeper for Adam, but it's not because my graph is not evenly spaced, and so it's hard to see. But how do you know? For this exact answer, we know because of the unit rates. Okay? So basically, finding your slopes will help you with that. Okay? And I'm sorry that the graph didn't work out because the graph paper was really awful, so I apologize for that. So basically, just focusing on these two, that gives you their slope. And so this one is going to be more than this one because 128 thousandths is less than 131 thousandths. And so Adam should have been steeper. Okay, so going back, today we will use constant rates to write linear equations and then compare the constant rates to see who is faster. How do you compare constant rates to determine which is faster? Is you have to have a common denominator of 1 minute, so hence that's why you do the unit rate, and then you can determine who's faster from there. All right, kiddos, that's all we have today. I'll talk to you soon. Bye.